There we go. OK. Morning, everybody. Thanks for coming in bright and early for this very exciting topic. We're going to be talking about one of the new features in SQL Server 2012 today. It's this change data capture, the CDC components for SSIS. Now, SSIS, of course, is my favorite topic to talk about. SSIS 2012 is really, really exciting because it's probably the biggest release for SSIS so far. Quick show of hands, who here is currently using SQL Server 2012 SSIS? OK. Who here has never seen 2012 before? OK, so good. OK. So I'm not going to go into details about all the new features in SSIS 2012. Really, it takes me about 2 hours to cover every single new feature of SSIS. If you'd like to know more about that, come find me in the pavilion. I'll be giving 2012 demos there for the rest of the day. Today, we're going to focus on one of the biggest changes, or one of the more important changes that we made in 2012, is the introduction of these CDC components. And as we'll see throughout the talk, CDC, stands for Change Data Capture, is a very important aspect to doing ETL. Most people don't realize that the functionality is there. CDC is actually functionality that was introduced into SQL Server in 2008. The components in 2012 make that CDC functionality a lot easier to use for the ETL developer. So before we go into too much detail, let me talk about a quick scenario around change data capture and why it becomes important. This scenario here, I hear it lots of times. It's your first data warehouse. So here's you, or a lovely silhouette of you. And of the people in the audience, who here are people who write SSIS packages? Most people, OK. Who are people that are DBAs that maintain the SSIS packages or run the SSIS packages? OK. And who here are just ops that mainly do deployment of SSIS only without actually doing anything else? Very few. OK. So that's the pretty common breakdown, and that's what I love about tech ed. We get that mix. So here's you. You own some data systems, right? You're responsible for these data systems. Usually, these databases were created for different applications. They were created in their own silos. They don't interact in any way, but they're full of data. And a business user comes along, and they think that they can, if they get access to that data, they can derive value, right? They can pull out data and get some insight that will help them run their business better. So they get you to write some SSIS packages that's going to pull the data out of these source systems, transform it, merge it together, put it into a data warehouse. And once it's in a data warehouse, it is in a format that's easy to consume. You can report against it. It's optimized to run the top queries. The business user can then create their reports, and everybody's happy, and the business user gets a promotion. And typically in this scenario, the first time you build your data warehouse, most people will do a full load. Okay, so they'll pull in the source data. They'll start by blowing away their data warehouse. They'll pull in the source data, do a full load into the data warehouse, maybe every week, for example. Right? Sunday night, you have a batch window, and you do this full load so that Monday morning, when your users come in, they can access the data and create the reports to use for the rest of the week. Over time, more people start using the system as they find that they really are getting value from it. Right? And the demands start going up. So now, weekly data isn't enough. People want now daily data, right? They want it to be refreshed faster and faster. And stuff gets more complicated for you because now you have new data sources that need to be integrated into the system. Right? And your data volumes are growing. Right? Your source systems have more and more data in them. And that means the data you're loading into your data warehouse, the volume's getting bigger and bigger and bigger. And the data warehouse itself is getting bigger. And so now these nightly full loads of the data warehouse aren't working anymore. They're taking too long to do, and you actually exhaust your batch window. Quick show of hands again. How many people here have a batch window to actually do loading? OK, so about half. One thing we're finding from talking to customers is that batch windows are going away, okay? Because users want access to the data faster. They want real-time ETL. They always ask for real-time, right? They don't want the latest results, and they want them now. And this is a lot harder for the ETL developer because you have a lot of data, and it's hard to move. Overall challenges for this scenario, right? You have more work to do, you have less time to do it, and you have more and more people using the system. A couple years ago at TechEd, I was doing a session on SSIS design patterns, and one of the things I talk about is incremental data warehouse loading. And a gentleman came up to me afterwards in the pavilion to argue with me which I always enjoy. He's saying how incremental ETL is just a waste of time because it takes too long. He just blows everything away and reloads because it's easier. And it's true. And I said, well, what about your batch window going away? Or he's like, no, we're always going to have a batch window. It's no problem. And he was wrong, but I'm Canadian and I'm too polite to argue with him, so I let it go. And I think it was like 6 months later, he emailed me and actually said, okay, you were right. And what happened was, so they had this batch window on Sunday. Sunday was their data loading day. The systems came down. They did data loads throughout the whole day. And their company acquired a company in Israel, a startup in Israel. And the Israel work week, the work week in Israel, they work Sunday to Thursday. They're off. Their weekend is Friday, Saturday, and they work on Sunday. Right? So now, even with the time zone difference, he just lost a huge chunk of what they thought was their safe batch window that they'd always have. Now, imagine a company like Microsoft, right? We, like the SSIS team, I'm based in Eastern Canada. There's a team in Redmond. There's a team in Shanghai. We have customer support offices all over Europe. Right? There is no time that you can actually have a batch window in, right? The systems always have to be up. They always have to be accessed. So the main challenges you're facing as an ETL developer is that when you have more data, right, it takes longer and longer to load. Does anybody else find that line funny, the more data, more problems? I found it was so funny. I laugh every time I see this slide, and I have yet to see anybody even crack a smile. So I'm kind of wondering, maybe I'm not as funny as I think I am. So basically, your processing time increases with the data volume, right? And it usually scales linearly. If it takes you an hour to move a pound of data, it's going to take you 2 hours to move 2 pounds of data, assuming there's no bottlenecks. If there's different bottlenecks, then your scale goes all wacky. But yeah, assuming there's no bottlenecks, it's going to move twice the amount of data, it's going to take you twice the amount of time. So the reverse of that is true as well. If you can cut your data in half, you've doubled your performance. Okay? So the solution to this is you want to do less work. Now, I tried this during my last performance review. My manager did not see it the same way. That by doing less work, I was actually doubling my performance. And that is why I'm no longer a dev and I'm now a program manager. Okay. So CDC, how does it work? So CDC in itself, change data capture, is the general ETL term. You'll see the term used in a bunch of different ways. The idea is basically you only want to capture changes. Any data that it hasn't been changed, you don't need to move. You just leave it where it is. And you're only working with the stuff that actually has to be moved to another system. Okay. SQL Server has CDC, and we're going to take a look at it in the next demo. The ideal scenario for doing CDC is that you can enable it on the source database. Okay, you want to enable the CDC or whatever change detection process you have as close to the source as possible, because then you're not moving extra data that you don't have to. Okay. So with the SQL Server solution, you enable it on the source database. It's going to start automatically tracking all inserts, updates, and deletes for you. Okay, so it actually scans the transaction log and will actually pull out all these changes for you without modifying your source schema as well, without changing your tables. And then you can easily consume the changes, and your life is good. So let's switch over. We'll actually walk through. I hope you guys it's not too early to be viewing T-SQL, but we are going to look at CDC for SQL Server. Quick show of hands again. Who here is actually using CDC today? Okay. So about 10% of the audience. So CDC for SQL Server is introduced in SQL Server 2008. It is a T-SQL API, a purely T-SQL API. Lots of stored procedures and functions that you can call to interact with it. And we're going to start off by enabling it on enabling it on a database. So here I have my CDC server database. Okay. It has just a single table in it, DIM customer. Always like DIM customers. And we are going to enable CDC just with this stored procedure here. So the key to the SQL Server CDC solution, there's a bunch of different ways to do change data tracking, right? The key to the SQL CDC solution is that it doesn't modify your source schema at all. Your tables stay in place. It's not going to break applications. You don't need to change anything. You don't need to do anything additional. And my VM is obviously waking up. But yeah, so like I said, there's a lot of different ways to do CDC tracking. What I really like about this solution is that it's not breaking anything else, and your table remains the same. So here's my DIM customer table. It hasn't been touched. Refresh. But when I enabled CDC on the database, I do see a number of system tables were added. Okay. These are all, and they're all in the they're all in the CDC schema here, except for that cis trans schemas. But yeah, these are the CDC tracking tables. This is where CDC is actually going to store all the change history and all the configuration data about your system. Okay. Now I'm going to, so once you've enabled CDC on the database, it's created these system tables. What you're going to do next is actually enable CDC on an individual table. Okay, so in this case, I only have one table. I'm going to turn CDC on for that table. And this is called the CDC capture instance. So I can be capturing CDC data from multiple tables, right, different tables. I have a number of different configuration options that I'll look at in just a second. And so once I do that, I see that I have a newly created table in the CDC schema specifically for my customer table. I'm going to look at, under programmability, I have some new table valued functions that I can actually use to consume the actual change data, and we'll take a look at that in a second. And it has also created some SQL agent capture jobs for me. Refresh this. Actually, there's some capture jobs. And so there's two jobs. There's a capture and a cleanup. So the way SQL Server CDC works is that it's an asynchronous process. Okay? It doesn't, so there's another technology called change tracking, which is synchronous. So basically, a change comes in, and change tracking will fire something out, and then once it's done, the change gets committed. CDC is asynchronous. The change comes in and is committed immediately. And then another process is going to run and look at the transaction log and extract everything that was actually changed. The CDC functionality is built on top of transactional replication. It actually works the same way. If you're familiar with the way transactional replication works at all, CDC is very, very similar. There's these two jobs that get created for every capture instance, or for every capture database, actually. And these things are going to start scanning and looking for changes, extracting all the different changes that happen, and putting them into the CDC tables. And we'll take a look more at those in just a second. There's some other functionality. So CDC is very, very flexible. Right? You can configure which tables you want to track. Which tables you want to track. You can configure which columns you want to track. By default, it'll track all columns in the table, but maybe you're just interested in a couple of different columns. You can actually have multiple capture instances per table. The scenario that you want to do there is you enable CDC on a table. Maybe some changes have been done to the schema, but other systems, other ETL systems are relying on that capture information being the same. You might create a new capture instance that picks up the rest of the tables and have your new applications using that capture instance. So I don't think it's too common a scenario, but it at least provides that flexibility. And one of the neat things is that CDC capturing works even if the table schema itself changes. If you add a new column, that column is just ignored from the current tracking job. If you delete a column, nulls just come out in the current tracking job. So you can actually keep your CDC capturing jobs in place even though the schema changes are happening. I can get more details about the CDC jobs themselves here, the SP CDC help jobs. This is going to give me information about the different capture jobs that were created. So there's going to be the capture and the cleanup. And I have some configuration options under that. The max number of transactions it's actually going to scan in a single run, the max number of scans it's going to do, whether it's continuous or not. Right, so you can configure this job so that you only kick it off at certain times. By default, it's just going to be constantly running and constantly scanning your transaction log. Same for the cleanup job. By default, it's going to run every night, and it's going to retain 432 minutes worth of data. So that comes out to 3 days by default. So if your ETL processes aren't running within that 3-day window, you want to make sure you increase this so that it operates with your ETL schedule. Another approach is to not rely on the cleanup job, but actually force the cleanup. So don't run it on a schedule. After your ETL is done, you tell it to clean up and get rid of the rows that you've already consumed. So that's another way to do it. But by default, it's going to create these two jobs with this configuration. I can also, at any time, I can also get information about all the different capture instances that are running on my database. So here I see the DIM customer capture I just created. We have a start LSN. I'll talk about that in a second. And I'll talk about supporting net changes. And this is another important concept for CDC, and we'll talk about this a lot more in the rest of the deck. But CDC has basically two main modes. One is all changes. So every single change that happens, I want to get a row for. So for example, somebody enters a new customer. That's a single insert. And then it takes them 5 tries to get their name right. So that's 5 update statements. Okay, when you have the all mode enabled, you're going to get back 6 rows. Insert, 5 updates. Okay. The other mode is called net. And net means the CDC server is going to roll up all those changes. So you get back a single change instead, a single insert with whatever the latest value is. When you're using net mode, it makes your ETL processing a lot easier. But it does push the work to your server. So don't tell your DBA that's what you're doing. Don't tell your DBA, hey, can I give your server more work so my job becomes easier? Because they'll usually say no. But there's other ways you can approach that conversation. Now, LSNs. LSNs are another important CDC concept. They stand for log sequence number. This is a binary representation of the sequence of events that happen within the log. Everything in CDC is LSN based, but they have these handy date time to LSN mappings. Okay, so let's just take a quick look at this. So I have a function I can run that will give me the minimum LSN, so the starting point LSN of change track data, and one that gives me the last LSN that I have. And then I have date time mapping functions. So you can actually pass in a date time, which is easier for you to work with, and it can be mapped to an LSN. Now, this is one of the tricky things with CDC, is that LSN range has to exist. You can't pass in a value that the CDC server, for example, if I pass in an LSN that maps to Monday and I only have data for Tuesday, CDC is going to return an error. Okay? Because that could mean that you've lost data. Right? You're looking for the Monday's data, but it's already been cleaned up or it's not tracked for some reason. So CDC is going to tell you that and return an error. Same thing if you go over. Right? If you ask, okay, so today is Tuesday, give me all the changes up till Thursday. Right? Sometime in the future, it's also going to give you an error. So you can only ever query for a range that it actually already has. Again, this is all when you're using the T-SQL interface. The SSIS stuff makes this much, much easier. So I'm going to make some changes. I'm going to insert 5 customers. Whoops. Yeah, insert 5 rows here. Thank you, help. I'm going to update 20 rows. So in total, I'm going to have 25 changes. Now I can run this function called get all changes, and it's going to have the name of my table name. This function gets automatically generated as soon as you enable a CDC capture instance. And I'm going to run it. And I get back all 25 rows that I modified. Okay, we'll see a couple of fields here. There's the start LSN field. That's going to be the actual LSN of when that operation occurred. It's going to be a sequence value. And when you're processing all changes, the sequence that things happen in are very important because you're going to need to apply the changes in the same order that they occurred to make sure that your database is in the right state. Okay? There's an operation field. This is going to be what type of operation it was, whether it was a delete, which is a 1, a 2 is an insert, a 4 is for the update, the old values. There's an update mask that tells you, it's a bit field that tells you which column was actually changed. And then it's going to actually have the latest data for the table. So that's all changes. So that gave me 25 rows. I'm going to do net changes. Now, I did 5 inserts and then 20 updates. There's going to be an overlap of the actual IDs there. So let me get my net changes. And now I only get 20 rows. Okay, so it's actually grouped together the updates and the inserts that I had. So it basically rolls them all up on the server, so I don't have to do any additional processing, right? Which makes it a lot easier for me as an ETL developer. I don't return the sequence value anymore because when you're doing net processing mode, you don't have to worry about the sequence. You already have the data in the latest state. You just have to put that into your destination. Now, if you don't want to work with LSNs, and that was one of the main feedbacks CDC got initially, there's actually a handy function that will generate a function for you, which is I always found was a bit interesting. But so it's SPCDC generate wrapper function. I give it my capture instance, I run it, and it's actually going to give me the T-SQL I need to create my own capture function, a function that's going to query the change tables and return data in a nicer, easier to consume format. Okay. So I've extracted what the net change function looks like here. I can run that. It's pretty long. The main difference between these generated functions and the ones that are created for you automatically are that these ones take in date times. So that created it, and I'm going to run it. And this takes in a date time instead of an LSN, which makes it slightly easier to map. Another difference is that it returns the operation as a text indicator instead of a number. So UN for update new, because there's a way you can get the old records as well. We'll take a look at that too. And so the last thing I wanted to mention is about this stored procedure, or this stored procedure right here, sys disabled DB. Now this doesn't pause your CDC capture instance. This destroys your CDC capture instance. Okay. So if I run this disable, so say I don't want to use CDC anymore, this is what I'd run. Okay, completes immediately, and if I look at my system tables, they are all gone, including all of my capture data. Okay, so just be aware of that. There's no prompt. Are you sure you really want to delete all your capture information? There's nothing like that. This is T-SQL. Your DBA, they assume you know what you're doing. So just be aware of that. If you do want to pause your capture job, so this is actually a customer story that I actually heard. They thought they were pausing their CDC job in production, but that's not what it did. If you want to pause, there actually is a CDC stop job function. So you actually turn off the capture instance, or pause the capture instance if you have to do that for some reason. Okay, so that's CDC at the server level. What we're going to see next is at the SSIS level and how it's so much easier to use. So I do like interactive sessions. If you guys have questions or anything, feel free to call them out.
You said you could control it at the column level, so you can specify only certain columns.
Yeah, the question is, can you control at the column level? And yeah, that's exactly what you can do. So as part of that, when you enable the capture instance, it takes in an array of tables, of column names that you actually want to capture. And you can update a capture instance after it's created as well to add or remove columns.
And then only those columns would show in those CDC tables.
That's right. When you query the change table, you'd only get back the columns that you actually specified. So for very long tables, or if you have a very specific application, if you're monitoring changes on one specific column, for example, you can do that through CDC. Question?
I assume this requires full recovery on the database?
I'm not sure whether it requires full recovery. We'll talk about the different modes the implications it has for enabling it later on. I'm not sure about the recovery mode, though. I'll have to follow up.
What is the impact of performance?
Impact of performance, that is a very good question. Actually, I have a slide at the end of the deck where I'll talk all about the performance impact of it. Yeah.
Primary key, only a single column, or could it be a composite key?
Question about the primary key. So the primary key isn't a requirement if you're doing all changes, but it is a requirement if you're doing net changes, so it has to roll up. I think it can actually be multiple columns. The CDC just needs a way to know how it's going to roll things up. Okay.
So if I enable CDC right now on all the records that are already in the table before will those be reflected in first, or will they just reflect out until they're
So the question is, if I enable CDC on existing table, what happens to the existing data that will get there? That is not tracked in CDC. We'll talk about that. There's actually two phases to implementing a CDC solution. You're going to have your initial load and then your incremental load. So we will talk about that next. There's one more. I'll take one more.
What about transaction log backups? Are all the transactions written to both the transaction log backup and the transaction log and the change tables?
So the question is with the transactional backup. I'm not exactly sure how the backup impacts this. I believe the change tracking table gets written out as part of the backup information as well. Yeah. The last question. Yeah.
Can you turn it on just for a period of time or just for a set of records, like only those in a certain year?
Can you turn on for a specific period of time or specific records? So you can't do it for specific records, like only track if this column value is, if this column value is equal to this type thing. It's going to track all changes that go into the table. As for time windows, you can always enable and disable it. So if you're doing something very specific and you want to track for the changing for that, you can definitely do that. Okay, so let me continue on. Again, we should have about 10 minutes at the end of the session for questions. So, quick summary. So CDC, SQL Server CDC, you enable it on your source system, your source tables. And it's going to start automatically capturing your changes. There's a number of configuration options. The two main functions you're going to be using are enable CDC on the enable DB then you're going to be using enable table. And all of the CDC functions and store procedures are all sys sp cdc, so they're easy to find. Underneath is using transactional replication. It has a lot of the same implications as enabling transactional replication in regards to backups and the requirements for what your database does. And this was so this works in SQL 2008 and later, so R2 and 2012 as well. And this is Enterprise Edition. CDC requires Enterprise Edition. Okay, so using change data capture within SSIS. Now, you can consume CDC data from SSIS with 2008. Right? As we saw, it's just a T-SQL query. You add a source, you query your change tables, you get the results back. Right? You don't really need any special processing. But as we saw, there's a lot of complication to CDC. There's a lot of intricacies that you need to get used to. The main thing that you need to do as an ETL developer is remember when the package last run, right? So you run it on Monday, you're going to store this timestamp. When you run it on Tuesday, you want to make sure you pick up all the changes from your last run until now. Okay. Now, there's samples out there that show you how to do it with 2008. As we'll see in 2012, these new CDC components just make the whole thing a lot easier. We partnered with a company called Attunity. Attunity has its own CDC solution. They're down in the partner pavilion. And they created these great components for us that come in the box in 2012. So first we have the CDC control task. So this is a task with a control flow. It is going to, you use this to mark your state and maintain and basically handle all of the state. You'll usually use this before and after your data flow. Okay? This is going to retrieve state from the database and then persist it back in. So your package just automatically knows where to start and where it left off. Okay? There's a CDC source component. This is just going to go straight to the SQL server and pull out all of the change data. It's going to make use of that state information that gets retrieved by the control task so it knows where to actually start. And it's aware of all the different processing modes that CDC supports, all changes versus net changes, all the different options about update masks and things like that. That's all built in, just with a simple dropdown. Finally, there's a CDC splitter. And the CDC splitter is going to, it's like a smart conditional split. It's going to split rows based on whether the operation is an insert, an update, or delete. You won't always use the CDC splitter task, the CDC splitter transform. Times you don't use it is when you're doing all processing modes, right? Because when you start splitting rows down multiple paths, you can't guarantee their order anymore. Just keep that in mind. So the general workflow with CDC is we're going to start with an initial load. And this is more of an interactive process. You're going to prepare your database in some way, and we'll talk about that more in the next slide. You're going to read all the data from your source system. You're going to bulk load it or write it all to the destination. And then you're going to record your date. Okay? You're going to record or the position. You're going to record when this, the LSN or the date of when this load was actually done. Next, you're going to do an incremental load. Incremental load is going to get the last date. It's going to read all the changes. It's going to process the changes, and then it's going to save that current date or the current position. Okay. Initial load is the tricky part. And there's two main scenarios in the initial load. First scenario is where you're doing it against an active database. Okay. So the ideal scenario is you're loading against a database that has no other activity on it. Okay. Because imagine what happens when you're doing this initial load, but actual operations are happening. So I'm going to mark that, hey, I'm starting. I'm going to do my load, and then I'm going to mark the LSN that says, hey, I'm done loading. But what happens if changes are occurring during my load process? Right? So the CDC control, the CDC components do actually handle that scenario that we'll take a look at. But yeah, the main scenarios here is I have an active database. I'm going to do a mark initial load start. I'm going to do a bulk load from source to destination, and I'm going to do a mark initial load end. The next scenario is where I have an inactive database. And this is probably the safer way of doing an initial load for CDC. Here I'm going to take a snapshot of the database. I'm going to tell it what the LSN is, or it's just going to try to automatically determine what the latest snapshot was, or the LSN was for that snapshot. Using Oracle terminology, this would be the flashback, right, or the system change number, the SCN. Control task, I'm going to mark CDC start, and then I'm just going to do a bulk load from there. Okay, so those are the two initial load scenarios. Incremental load, this is more of that automated process, right? This is the package that's going to run on a schedule and pick up changes whenever, on whatever frequency you tell it to run on. you're going to use the CDC control task to pick up the state. So to remember what was the last LSN that was actually used, it's going to store that in a package variable. You're going to use the CDC source to actually read all the changes from the change table since that last run. And then you're going to process the change rows within your data flow. And depending on your processing mode, you're going to have the data flow is going to look very different. And finally, at the end, after your data flow, you have another control task that's going to mark the process again. We're all done. So that scenario that I was talking about, the first scenario where there's actually changes going on to your database while you're doing the initial load, CDC tasks do handle that, and there's a special flag called the reprocessing indicator. Okay? You'll see that in the source. So when you enable this, it's going to add an extra column called reprocessing to the data flow. And that's going to be set to true if there's any potential that that change overlaps with your initial load. Like if it's close to your initial load times, the initial load LSNs, it's going to set that flag to true. That way you can do special error handling, special processing. So for example, if you're getting, if the processing flag is set to true and it's an insert and you're getting a primary key error, probably means you processed that row already and you can ignore that issue. Okay. So usually the process is during my initial load, I'm going to do my initial load first. I'm going to run my incremental load package once interactively with the reprocessing flag on so I can make sure that I am in a good state. And after that first run, when I'm sure that, yes, now my source and destination are in sync, then I can start running the incremental load on a schedule. So actually, let's switch over to SSIS and take a look at what all this looks like. OK, so here's SSIS 2012. Here is the CDC control task. This is going to, so again, I have two packages here. I'm going to do my initial load first. I'm going to start with my CDC control task. I'm using that scenario 1. I'm going to do the mark initial load state. So my database is active. I'm not loading against the snapshot. And I've configured it to connect to my source. I have a control operation. It's going to be marked load start. I'm going to store it in a variable within my package. And I'm going to say persist the state to a database too. And this is configurable. If I click new, it'll actually give me a T-SQL that I can create my own states table. And I can name that state. So if I have multiple packages running against multiple capture instances, I can track in the same table, but just name the state name differently so the packages know which state is theirs. OK, so that's the start. My initial load is a very simple bulk load, source to destination. And then I have my CDC end. And the main difference here, it's configured the same, except for this is now mark initial load end. So again, the CDC components, always remember that. You have the CDC control task first, you do data flow, and then control task at the end. So let's run this. And note, I didn't have to think about LSNs at all in this scenario. I didn't have to think about dates. Everything is just handled for me automatically. Click run, my rows transferred. Now I'm going to run a package that will actually make changes. By the way, I'll make all these packages available on my blog, mattmason.com. I'll post it all up, and you can just walk through it yourself as well. So this package is going to insert 10 records. It's going to update 5 records, and it's going to delete 2 records. So in all, I have 17 changes, but there's overlap between these changes. Right? So sometimes I'm updating an already inserted row, and I'm deleting a row that I just inserted as well. So there's going to be some overlap. Now let's show what these changes look like. And here's a demoing trick for the CDC components. So I have a CDC control task here that's retrieving my state so it knows where to start. And I'm never persisting or updating that I've done this load. So I can actually run this package multiple times. It's going to keep reading the same change data because I've never updated my state to say, hey, I've basically moved my position ahead. So let's look at the all changes. And I'll add a data viewer here and run this. And the first time I run through, I get no changes. This is a very confusing thing. The first time you run your incremental load package, it's only going to pick up changes that potentially conflicted with your initial load window. Right? So this is the first time you run your package is meant to be interactive. You're going to run it, and it's going to pick up anything where reprocessing indicator would be set to true. Okay? second time I run my package, I should get changes. Now I get changes coming up. Okay, so I see I have the LSN. I don't really need to track that LSN. I don't need to know about it from my ETL perspective. I have an operation. 2 is going to say it's an insert. 4 is going to be an update. 1 is a delete. So here I have my 10 inserts, my 5 updates, and my 2 deletes. Update mask, again, it tells me which column was actually changed if I'm concerned about that, if I need to do that sort of tracking. And then, yeah, I have the rest of the data, and the final column is that sequence value. But the data that comes out of the CDC source is already going to be sorted on that sequence value, so it will be in order. So you just have to process the changes as they come in. So I use the CDC splitter component, and that sends 10 rows down, 5 rows to update, 2 rows to the delete. Basically it. And let me switch over to my actual incremental load package that's actually going to commit the changes. And this is what it's going to look like. Just resize this. Oh, it's too small. So at the top, I'm going to do get processing range. Right? Again, CDC control task is going to read that last state. I'm going to actually do my data flow transfer. And within my data flow, I have my source. I'm going to split. I'm going to do insert, update, and delete. Now, I could have OLEDB commands in here for the updates and deletes and apply them row by row. Performance-wise in SSIS, one of the first things I look at to improve a package's performance is to remove all the OLEDB commands. It's always better to do everything in batch. Okay? So what I'm doing here instead is I'm staging all my updates, I'm staging all my deletes, and then I'm going to do 1 batch operation or 2 batch operations within the control flow afterwards. I'm going to say update from and point to the table, delete from and point to my staging table. Okay? So I just do it all in a batch operation. That will perform a lot better than doing row by row inserts or updates. Again, it really depends. The way you design your package really depends on your data loads. How many changes are you actually processing? If you're running this package every couple of minutes, if you're running a package every half hour and you're only processing 5 to 10 changes, you're not going to see a big perf increase for actually doing staging. If you have a very high, lots of transactions going on, then staging is definitely worthwhile. So like I said, within the control flow, I do my data flow, and then I do my updates and my deletes in one batch. I mark the end, so it automatically persists the state, so it updates my position. So the next time this package runs, it knows where I left off, and then I simply truncate the staging tables. Let's run that. My data flow I see again. So this was using a net processing mode. Actually, let's take a look at the CDC source here. I was using a net processing mode, so it actually did all the roll-up on the server for me, and I get my changes back. And yeah, so 12 changes in total, and 9 inserts, 2 updates, 1 delete. Okay. And that's pretty much it. Are there any questions about the CDC components? Mm-hmm.
So do you truncate the change tables in the source system also,
So the question about truncating. So in this case, I'm just truncating my staging tables that I created here. To get rid of the change rows that you've already consumed, you wouldn't want to truncate directly. What you do is you'd launch that cleanup job. So tell it, now clean everything up. Right? It created the capture and cleanup job. You can explicitly clean that up. Okay. Any other questions? Yeah?
So the net option enforces the ordering?
So the question is about whether the net option enforces the ordering. Yeah, you don't need to worry about ordering with the net because it's already rolled up to the latest change. So the server has already collapsed all the updates in the order that they occurred so that the record is going to be in the latest state.
So if you had an insert, that was then updated, would the insert include those updates if you already had that record?
Exactly, yeah. So if you have an insert and then updates for that same key, it would be collapsed so your one insert would have all the latest values for that record. That's right. So again, you see how the net mode makes ETL processing a lot easier. Yeah.
On the net mode, is the detail always still there?
For the net mode, is all the detail there? Yeah. Every column that you're tracking is going to be included in all the rows. There's that update mask field that you can actually tell which specific column changed, and we'll look at that and exactly how to process that in the slides afterwards.
So it's always there if you need it, but you can do that server
So when you run it, the detail is always going to be there in your change rows. Yeah. Question?
So how does your CDC process hook to Oracle?
How does the CDC process hook up to Oracle? Great question. I will talk about the Oracle stuff later on. So the great thing about this solution is it works for SQL Server and Oracle, as the title suggested. From the SSIS perspective, SSIS doesn't even know it's talking to Oracle. The way the solution works is SSIS thinks it's talking to SQL Server, and we'll see. We do some tricky stuff to get everything working. Yeah. How does changes to source tables? You mean changing of the schema of the source tables? So the CDC capture instance is going to keep working if you change your schema. So for example, if you add a new column, it will simply be ignored because it wasn't part of the original columns when it was created. If you delete a column, the values will come out as null in the CDC instance. So that's what I was saying. You can actually create multiple capture instances. You can have an existing capture instance to service the applications that are currently connecting. And if you have a new API, you're making schema changes, you can create a new capture instance that the new things will access.
So if you delete a column from CDC, it starts coming across null. Is that going to update your target to null?
So that's a very good question, yeah. So if you delete the source column, it starts coming down as null. Yes, you would end up updating your target as null unless you've updated your SSIS package to account for that. But you can also be checking, right, yeah, if you're updating specific columns, well, we'll take a look at that. There will be a change flag that you can actually check to know whether or not you need to update that column. I'll take one more question. Is there another one? Yeah.
Just to be convinced.
Yeah.
What would be the argument of change from traditional item, for example, hash byte or merge, the
Yep.
CDC style versus
So the question is, why would I use the server-based CDC versus the traditional ways of doing change detection, like building a hash column into the thing or a last updated field or anything like that? If you're using the hash bytes, right, there's a whole bunch of reasons why you'd want to use a hash column, right, to do change detection. That's still very valid and very useful in many ETL scenarios. I think the advantage of the CDC solution, the SQL Server CDC, is it's a lot easier. You don't have to roll that yourself. You don't have to worry about generating the hashtags, making sure your hash algorithm is right, making sure your columns are concatenated in the right way. Right? It pushes the work to the server and lets the server do all the tracking for you. There's also, we'll talk about different scenarios. I mean, the most common scenario for CDC is to keep two databases in sync. Right? But there's other applications as well. You might want to do something when a specific column changes. Right? For example, I saw a customer, when a specific field changes in a certain database, they kick off a whole workflow and a whole process because they have to regenerate scripts, they have to regenerate databases, they do provisioning, right? Every time something changes, or a configuration value changes, and they do things. Right? So there's multiple uses for CDC. It's not just about keeping things in sync, but that's probably, like, say, 90% of the cases. So that's the main thing I focus on here. Okay, one more. So the question is, so if you're using the all processing mode and you want to apply your changes downstream in order, how would I do that? And you'd actually do that with a script. And so I'll talk about that next when I go back to the slides. I'll talk about how you'd lay out your data flow for each of these different processing modes. Okay. Script is probably the best way to do it. Okay, let me switch back to the slides. Quick summary, 3 components. You have the CDC control task that does all your state stuff. You have the CDC source that's for reading all the change data. And then you have the splitter component. It's like a smart conditional split. It's going to send the data out. Again, you can consume CDC data with 2008 using SSIS. But the CDC components make it a lot easier. And these components work against any source SQL Server, so source SQL Server running 2008 or R2 or 2012. The source doesn't have to be 2012. But the CDC components that I just demoed are SSIS 2012 only. Okay, so I showed really briefly what the CDC source UI looked like. And one of the things you can drop down is the CDC processing mode. So the next couple of slides, I will go over all the different processing modes and kind of when you'd use them and what the changes will look like and what your data flow will look like to actually do the processing for them. First, you need to decide which processing mode you're going to use. The first question you need to answer is, do I want all or do I want net? What are the scenarios here? All changes. Do you need to record every change? Okay, is every change important to you for compliance reasons, for logging reasons? Right? So yeah, for example, you actually need to know that every single change occurred and maybe who even made the changes and actually log those things in. Is anybody in an environment like that where they think they have to log every single change? Yeah, okay, so about 10% of the audience. I think that's about right. The other thing is, do you really enjoy complicated ETL? Are you looking for job security? Right? Do you want to write a script component that nobody else will understand? So if either of these are true, you probably want to use the all changes mode. Net changes. Do I want to push the work to the source system? All right. Sometimes you can't actually do that. The source system, even enabling CDC, there is overhead to it. Maybe that is too much. Enabling net changes in the CDC, it increases the overhead that it does add. I'll talk about exact stuff. Overall, it's less than 10%. We'll go into details about that. But yeah, there are some environments where you just can't push that to the source system. You're going to have to do the change tracking yourself. But in the ideal scenario, it's much easier when you do push that to the source. The next thing you need to decide is, do I need the update mask or old values? Okay. And that's usually around, do I need to do something specific when a column changes? Do I actually implement business logic within my SSIS package to validate a change? Like, for example, a field can go from A to B and B to C, but can't go from A to C. All right? Do you actually validate that sort of thing within your SSIS package? Do you need to know when specific packages change? Another common scenario is if you're not using the slowly changing dimension wizard component, you have your own slowly changing dimension custom processing logic, and you want to easily be able to see, did this type 2 field change, and then do specific logic for that. So these update mask type things will help you with those types of changes. Okay. So in this scenario, this is where we get all my changes. So I've added a new customer key 50, Smith, and then I did an update because I spelled the name wrong. So I changed it to Smith with an I to Smith with a Y. I did an insert of Jones, and then I deleted Jones because Jones wasn't really a customer after all. And then I did an update to an existing record to key 10 and changed it to Williams, and then I did a delete. So in total, I have 6 changes. So if I was using the all processing mode, I'd get all 6 changes back in this order. The way I do my data flow is I'd actually have to use a script component. Right? That's the only real way to do it, because you need to first check what the operation was, and then call the appropriate insert, update, or delete on your target system. Okay, you can't just use an OLEDB command, because the OLEDB command is going to do a single statement. It won't do that optional. Well, I guess you could code your SQL to do it that way. But yeah, usually you use a script component to do all the processing and to make sure that things get processed in order. Again, when you're doing the all mode, you'll never use a splitter, because once you start splitting rows off multiple paths, you can't guarantee their order anymore. All with old values. This is the mode that will give you the most number of rows coming back. So in addition to those green update rows, you have some yellow update old. So this is actually going to give you the old value. Okay? The time you'd use this processing mode is if that old value is important. If you want to log for compliance reasons, for example, you need to say this column changed from this value to this value. Right? Or if you want to do any sort of verification, you can use this old processing mode. Processing looks the exact same. You'd use a script to actually apply the changes, but you might have some additional workflow before that to validate the change or to check the change or to log the change. Right? You'd have some additional thing in there. Now we have the net processing mode. Net's going to give you the fewest number of changes. Actually, no, that's not true. Net will almost give you the fewest number of changes. But again, net is where everything gets rolled up on the server. Okay, so for this, I get a single insert. I get, with the latest value, I get an update, I get a delete, and that customer that I inserted and deleted doesn't show up at all because that record doesn't exist anymore. My ETL doesn't need to know about that. Net processing mode is what I showed in the demo. I have my control flow is a bit more complicated. I do my get range, I do my data flow, I do my bulk update and bulk delete, and then I have another control flow, CDC control task. And in the data flow, I'm doing a split, and I'm going to do my inserts directly. I'm going to stage my updates and my deletes. Again, I can use OLEDB command instead of my updates and deletes, but for performance reasons, you always want to stage and then do things in batch. Net with update mask. If I'm using this processing mode, it's actually going to include a separate column called with the name underscore changed. And that's going to be a Boolean flag to tell me whether that column was actually changed. Okay, so for example, when there's an insert, they're always going to be true. When it's delete, it's always going to be true. For the update, I change the name so that key flag is false and the name flag is true, right? So if I want to do a specific logic, specific processing logic, according to that, when this column changes, I can do it here. Data flow, it can be complex. It doesn't need to be this complex, but basically what I was doing here is I was including a conditional split that's checking, was this column changed? And if it was, I'm going to do some specific logic for it. Okay. Otherwise, it looks a lot like the net processing. Net with merge. Net with merge, it is meant for processing the results using the T-SQL merge statement. Anybody use T-SQL merge? Comment? Maybe about half. Yeah, T-SQL merge is my favorite SQL Server statement for ETL. It is great for performance. What it basically does is it takes a source table, it takes a destination table, and merges them together. And you can perform actions based on whether the row is new, whether the row has been changed, right? It does field comparisons, or whether it's a delete. You're going to be processing delete separately because you're only processing change data, right? You're not going to have all the records, and because you don't have all the records, they would have been flagged as delete. So you'll process the delete separately. But what this does is it rolls up all the inserts and updates together. So you just stage them all at one time and then do a single merge statement to make all the changes in one shot. Okay, so it ends up looking like this. CDC, that looks a lot like net, except for I don't have an output for inserts because I don't get separate inserts. Everything's treated as an update. I stage both of these, and then I do my deletes, and then I do a merge all in one shot. Sense? Okay, so CDC for Oracle. Any question about processing modes before I go into the Oracle stuff? No? Okay. So yeah, it's quick show of hands. Who here is using Oracle today? Okay. Typically for legacy systems, right? And you're migrating off and moving to SQL Server, of course. That's well, you are at a Microsoft conference, so that's what I assume. So like I was saying, the great thing about the CDC solution for the Oracle's CDC solution in SSIS is that you don't, once you set it up, from the SSIS perspective, it looks just like SQL Server. You don't have to do any processing just because, any special handling, just because the data is coming from Oracle. Okay? We make it nice and easy to move all your change data out, move all your data out of Oracle and into SQL Server. So basically how it works is you're going to have Oracle, your database, you need to run LogMiner. LogMiner is going to monitor the transaction logs, make these changes available for us. There is a CDC designer component. Using this component, you're going to create a capture instance. So you pick the tables, you pick the columns. Basically, all the configuration stuff you do for SQL Server CDC, you're going to do for the Oracle table as well. Okay. Then there's a CDC service. This is a Windows service that's going to run on your Windows machine, and it's going to talk to LogMiner and communicate with LogMiner to pick up all the change data that's coming in. And finally, there's a SQL Server. There's going to be a local SQL Server instance that the service talks to, and it's going to create mirror tables of what's in your Oracle database. Now, it's not going to mirror all the data. It's just mirroring the schema. Okay? And then it's going to enable SQL Server CDC on that table. So what it's actually doing is it's tricking SQL Server into thinking it's tracking CDC on a SQL Server table, when really the change data is coming from Oracle. Okay, so when changes occur in Oracle, the CDC service reads them, then puts them directly into the change tables. So it's sort of a tricky, I don't know, I find this a very clever solution. Okay, so the only thing you're really mirroring here, you're mirroring the schema, not the data, and all the change data is actually just going to go straight into the change tables. So that when you're consuming these changes, or when SSIS is consuming these changes, it thinks it's talking to SQL Server. It doesn't need to know that the data is actually coming from Oracle underneath. Okay. Now, I'm not going to have time to go into in-depth about the CDC for Oracle. I'm just going to cover a kind of high-level overview of how you set it up. It is pretty simple. But we are going to do a webcast. It should come out pretty soon. I'll post on the SSIS team blog. They'll go into in-depth, click-by-click, exactly how you go through and set it all up. But at a high level, here are the main components that we need to go through. Now, thankfully, not all SQL Server customers are Oracle customers, so we don't install the Oracle components by default, but they're on the SQL Media. On the SQL Media, under Tools, Tunity, CDC, Oracle, there's going to be two MSIs you run. First one is going to install the service. Next one is going to install the CDC Designer. Service configuration, it's like setting up any other service. You're going to name it, you provide your description, you're going to provide the service account information that the service is going to run as. You'll provide account information for the local SQL instance that it's going to talk to. And you're going to give it a password that's going to use to encrypt all credentials and connection information. There's the CDC designer component that I talked about. This is what you're going to use to actually create your CDC capture instances on Oracle. Now, the CDC designer is an MMC snap-in, the Microsoft Management Console snap-in, and it has a wizard-like interface. I'll show some screenshots on the next slide that you basically walk through. I'll guide you through setting up a new capture instance. So you're going to have multiple capture instances for a single CDC service, and an instance essentially contains the Oracle database tracking information, the tables and columns being tracked, and all of the SQL Server mirroring information as well. Designer, like I said, it's a wizard-based interface. I open the MMC, I right-click on my service, I say new capture instance. I pick the tables I need, I pick the columns I need, basically like setting up a SQL Server capture instance as well. And then finally it goes through a wizard. It's going to give me some SQL that I need to run on the Oracle side, or I can run actually directly that's going to configure LogMiner to pick up the changes as I need them. And then I'm ready to go. Once my capture instance is created, I can manage the capture instance. I can stop it, I can pause it, I can reset it, I can regenerate all my setup scripts in case I need to reset up my Oracle databases. And that's basically it for the CDC for Oracle. Right? When consuming the changes becomes the exact same, like I mentioned, because it's just like talking to SQL Server. SSIS thinks it's talking to SQL Server. Question?
You said that some SQL is run on the Oracle side. Is that DDL changes on the Oracle side?
I'm not sure. Actually, I meant to pull up a script to show exactly what it is. I believe it's not changing your underlying schema, or it's not changing the table schema. It's actually, I think it's to configure LogMiner to actually, so it starts tracking the changes, or it configures it in a way that the service can actually talk to it. I can pull up an example when, afterwards.
I think if you set up replication using Oracle as a publisher, it will create triggers on the Oracle tables. I'm just wondering
if it's a trigger-based system, that I'm not sure. Well, I can follow up on that. Question?
If your source system in SQL Server is a 2005 database, but you want your CDC to be in 2008,
yep.
Do you need to do replication from the 2005 database to a 2008 database in order to set up CDC, or?
So the question is, your source database is a 2005, but you want to be using CDC and you have a 2008 instance. Yeah, you want to set up a replication over to the CDC to 2008 instance. Attunity, the ones who created the solution for us, they actually have a separate solution as well that works against SQL Server 2005. So you can talk to them for the details there.
That CDC service for Oracle sits on a Windows box?
The CDC service for Oracle does sit on a Windows box. That's right.
And can it be any box, or do you want it on the SQL Server?
It can be any box. You usually want it on the same box that the CDC capture instance is. And that doesn't have to be your primary SQL Server instance, but you'd have a SQL Server instance that has all the mirroring information.
What's LogMiner?
LogMiner? I'm not an Oracle person. It's a part of. Yeah, it's a part of Oracle. I believe it scans the transaction log, kind of like the log reader in SQL Server.
It scans the redo logs. Does the CDC service, does it have a polling interval for how often it reads the LogMiner?
Yeah, the polling interval and everything like that is all configurable through the CDC designer. Okay. So one more? Yeah.
If the source app writes a full column to a table, what happens with the update mask?
Writes the full column to the update mask. So the update mask is going to be
the full range of columns.
The full range of columns, and it's going to be, well, so it's a bit field, right? For every column, it's all the bits are going to be set on. So every column is going to be modified. It doesn't do some netting now. Oh, actually, no, it does detect actual changes. Yeah, it will. So if you did an update but you didn't actually change the column, I believe it doesn't actually set the bit flag to true. Okay, so supported versions, like I said, with SQL Server, the server-based CDC is supported in 2008 and up. For Oracle, it's 10G R2 and 11G Release 1 and Release 2, and there's some patch set information here, required patches. So the common questions we get, first is, do I need any special permissions on the SQL Server side to actually enable CDC or use the CDC solution? The only time you need a special permission is when you're doing that, you're getting the initial LSN during the initial load, okay? Because we actually call a store procedure for a replication store procedure, REPL increment LSN, and that requires DB owner. But to actually consume the changes after the initial load, there's no special permissions required. Well, enabling CDC performance, yes, will enabling CDC impact performance? Now, the most common question I get from people is probably where can they get one of these black MSBI shirts? But the most common SSIS question I get is all around performance, right? Performance is definitely a concern when you're doing ETL work or doing database work in general. So short answer is yes. Enabling CDC is going to have some overhead on the source system. So the overhead is going to be similar to enabling transactional replication. One of the good things about CDC and the difference between CDC and change tracking, and I have a link to a white paper that talks about the difference between CDC and change tracking, is that it's an asynchronous process, so that it's not blocking rows from being committed. The scan job is going to run in the background on another thread, so it doesn't affect actual insert performance. But it does add overall processing overhead to your system. The main thing with CDC to keep in mind is that it's going to increase your data size, because it's actually tracking it. You have a new row for every change that's going in. Right? So if data size is a concern, you either want to increase your cleanup frequency or increase the frequency that you're actually consuming those changes so your change tables don't get too big. Okay. This is the biggest performance impact, is that it prevents minimally logged operations. Okay? So if you're doing large bulk inserts, it will prevent those from being minimally logged and have an impact on performance. So this is fine in most OLTP systems where it's a lot of single row updates or small batches. But you wouldn't want to enable it on, say, if you have a data warehouse that you're already doing bulk loading into, and then you have a data mart that you're pushing the data out to. You wouldn't want to enable CDC on that data warehouse, because now your bulk loading is disabled. Okay, so something to keep in mind. That's where you'd start using the whole change tracking, sorry, not change tracking, but you'd use something like the hash columns, for example, to figure out whether a change was actually changed or not. So there's a white paper, and I'll link to that on the next slide. I'll talk about all the different performance aspects to CDC. Overall, they say with a standard workload and all the workloads they ran through, it's less than a 10% actual overhead, assuming that there's no I/O issues already. If the system is already I/O bound and having I/O issues, enabling CDC can have it will have a bigger impact than if you don't have any I/O issues, because of the increased processing needed, increased stuff going on in TempDB especially. Overall, the overall recommendation I got out of the white paper is if you don't need net changes, don't enable net changes, because it does reduce the overhead.
10% overhead, is that mainly CPU,
CPU processing, the white paper goes into actual details, but they say that's the blanket number, less than 10% overhead for the system. Yeah. That is a good question that I need to check out. So the question is, if I drop the table and then enable it, I think if you drop the table, it actually disables the capture job as well. That when you do the SP info for all the CDC capture information, there's a column that says drop pending, and so I think it actually tracks that.
Yeah, so that's going to reset all your SLs, right?
Yeah, it reset everything. Yeah.
How does the CDC work against like the Dynamics repository model for CRM and AX?
So the question is, how does CDC work against Dynamics model? I'm not sure. I don't think I've heard of customers using that before. I think it depends on the workload that's actually going in.
All the time.
Oh, so AX is...
And also a metatable repository, right? So you have base, then you have extended basically two-value pairs for data capture.
So yeah, so reading data from that sort of system where it's not a straight table mapping, I don't know if CDC is the best solution for that. There are custom SSIS connectors that can actually connect to something like Dynamics, CRM and AX, that can read the data in a tabular format that makes it easier to process with your ETL. But yeah, so you probably wouldn't want to use CDC in scenarios like that. Question?
Does CDC work on an XML data column?
CDC work, I think it treats it as a blob data, but yeah, it can. So quick, books online resources, there's an overview of all the CDC components. The second one is that white paper about tuning change data capture performance. They talk about the different factors, the actual impact of enabling CDC on your system. And then the last thing is about comparing change data capture and change tracking. So again, change data capture, lots of functionality. It's an asynchronous processing thing, lots of configuration options. And change tracking is Asynchronous is basically like a trigger-based thing. Some change comes in, and then you do something. Like you flag a column as the last update column, or you do something. But it's lighter weight than change data capture, but it has a lot less functionality. And it doesn't do anything like history tracking. So if you want history, CDC is what you'd want to use. But yeah, this white paper compares the two and when you'd use one over the other. And that's it. Like I said, be sure to check out the BI Power Hour later on today. That was going to be a good time. And there's some hands-on labs. I will be at this booth. I will be at the Breakthrough Insights booth all day. If you have CDC questions, or if you're looking for demos about SQL Server 2012 or SSIS 2012, I'm more than happy to go through them. The new certification exam, and then, yeah, you can find me later here. So thanks a lot, guys. Be sure to, here's my contact information, Twitter. If you have any questions, feel free to email me. Thanks.